Cooper Lighting Solution Technician Network proudly presents 0 to 10 Volt, a guide and troubleshooting, 4th quarter 2023. In this guide, we will cover the what are, what about, what should, what does, and what else. What are 0 to 10 volt controls? Well, 0 to 10 volt is an analog lighting control protocol where the control signal is DC voltage that varies between 0 and 10 volts to produce varying control levels, hence called 0 to 10 volt. Two standards are recognized: current sourcing and current sinking. Current sourcing, or source, is providing the current. Think the 0 to 10 volt DC current is produced by a control station, and the lights are brighter or dimmer based upon the amount of voltage applied from the control station, or source. In current sinking, or sink, we're dissipating the current. The light produces the voltage, typically 10 volts DC, which is then sent to a control station, which uses a resistor to ground the voltage. This grounding of the voltage allows the 10 volt DC to either increase, no grounding, or lower, a lot of grounding, which causes the voltage to go down as low as 0 volts. This means that the control station in a sinking system does not produce any voltage at all, but instead regulates the 0 to 10 volts, which allows the light to go to the correct level. All dimming in a sinking system is really done at the light and not at the control station. Remember, a sinking system and a sourcing system are not compatible and should not be used together. For a driver and controller to be compatible with each other, one must be the source of the current and one must sink it. What about Cooper 0 to 10 volt controls? Cooper Lighting Solutions provides a variety of 0 to 10 volt control products, which can also integrate with third-party devices such as shades and motors if they use the same 0 to 10 volt control protocol. For lighting, 0 to 10 volt fixtures need 4, or if we want to include the ground, 5 wires. The color for the wiring has changed, and after January 1st of 2022, we've seen the introduction of the pink wire. The power to the fixture will be controlled via a relay, on-off, so that's going to be where your higher voltage is located. The dimming to the fixture will be controlled via the analog 0 to 10 volt signal, and that is our low voltage. What should we check? Always test both 0 to 10 volt lines for DC and AC current before any testing takes place. For DC, test between the two 0 to 10 volt wires. For AC, test each wire to ground. If AC voltage is detected, do not move forward without reviewing the wiring with the EC. This could be real or phantom voltage depending on how the EC installed the wiring. Drivers should be assumed to have an industry standard draw of 2 milliamps max. Check your output spec of the 0 to 10 volt controller for maximum controller driver count. A single control with 50 milliamp capacity can operate 25 drivers. A single control with 20 milliamp capacity can operate 10 drivers. Drivers should have isolated Class 2 and Class 1 circuitry. 0 to 10 volt wiring can be confirmed by the following. Removing the 0 to 10 volt wiring from the control, the light should be at 100%. Touching the low voltage 0 to 10 volt wiring together, or shorting them, your light should go to low end. Only the appropriate lights should go to low end. All the way to low end. If lights are stuck at low end, and not going full bright when removed from the 0 to 10 volt control, there's a potential for a cross to be between the fixtures. If the lights do not respond at all, or they all are dim, but they do not dim to low end, there are too many drivers. You are drawing more amperage on the 0 to 10 volt line than allowed. Please verify the 0 to 10 volt output max in the spec of the controller and the milliamp 0 to 10 volt draw from the driver. Some fixtures have several drivers, so there's not necessarily a one-to-one fixture count to driver count. What does it look like? For a drawing based upon Cooper Lighting Solutions relay switch packs, each individual 0 to 10 volt controller will be assigned a designation, and the corresponding fixtures in the space are intended to be wired to that single controller. These may be referred to as zones. In this example, fixtures A should be wired to the relay switch pack A. Fixtures B should be wired to relay switch pack B, and fixtures C should be wired to relay switch pack C. Each zone, A, B, and C, should be tested for 0 to 10 volt dimming and relay power specific to each zone before being considered wired appropriately. Once tested is passed, this will mean the power and dimming follow the plan-specific zoning, and we are not mixing relay power and dimming across zones. What else about 0 to 10? Almost always do not mix 0 to 10 volt wires from different controllers. But if we're troubleshooting and testing, the lowest voltage on the 0 to 10 volt lines wins, if you are curious. When everything is full on and full bright, it gives the illusion of being wired properly. Every dimming line and every relay line should be tested for full dimming capabilities, or as capable with the specific driver and LED combo you have, and also the appropriate zoning. For specific zone control testing via Wavelengths CAT, you can easily use a direct wired connection via Cat5 cabling from a CAT wall station to the single relay switch pack. This will help eliminate any crossing or miswires of the 0 to 10 volts or relays. Remember to always test before touch any wire and always abide by all IEC and safety standards. Thank you. Safety first. And if you need any controls tech support, please refer to the information in the bottom left. Thank you.